data science and have this entrepreneur's perspective, sa lalo na po sa mga estudyante natin ngayon, you can indeed increase your value, no? This is the numbers that we got from our MS Data Science students and MSIB students. Mainly the idea is that we make sure that they understand that data should be at the center of whatever things they do, no? Minsan po ang problema kasi hindi align ang deliverables ng industry, society at academic na community. Society values impact and service, industry value value creation ng critical, academic, publish or perish, no? But if you put data, they will be all aligned. So, and again, this is the main reason, no, kung bakit mas may agility kapag data yung nasa gitna. Opinion versus opinion, panalo ang mas malakas na boses. But if we have opinion versus data, nananalo ang data. Thank you. Thank you so much. Thank you po. Thank you, Monique.
Thank you. Thank you so much, Mr. Monterella. Thank you. For those questions are related to his presentation, we'll try our best to answer it in the Q&A tab or later in our panel discussion. So now, for the next presentation, it will be about practical data science. Is the founder of Future Generation International, a NUS Gold Medal awardee, a distinguished alumni Cesar E.A. Virata School of Business, UP Diliman, a distinguished alumni Divine Word Academy of Dagupan, Philippines. Please welcome Mr. Wilson Chua.
Thank you, Monique. Let me check my microphone. And can you see my slides? Let me check that you can see my slides.
We can hear you, but no slides yet.
Here you go. Can you see it now?
There, you can see your screen. Thank you.
So good morning, everyone, and I'm so honored to be speaking right after Dr. Chris Monterola and before Dr. Wilson Tan. I hope to be able to share my journey, no, in data science. So, for me, data science is all about crunching numbers and telling a compelling story. We tell insightful stories that leads to action. Yan ang importante. Our stories from those data or numbers must lead to actions. So I first applied this to the problem that is dengue. And we zeroed in on using satellite data that was used for agriculture and repurposed that to identifying stagnant water. Why? Because that is where mosquitoes live. And so if you then pass on that data to the local government officials, they can then institute mosquito control operations that will keep the population of mosquitoes down. And since mosquitoes are the vectors of spread for not only malaria or dengue, but also Zika and chikungunya, you can see the large impact that this has. Unfortunately, when I shared this idea to PhilHealth, hindi nila gets. They did not get it. No? If they were to hire, let's say, AIM, and they paid them 1 million a month for a year, that is just 12 million. Our estimates show that PhilHealth could have saved up to 2 billion pesos a year from avoiding paying hospital fees for dengue alone. So, kulang doon eh. Anyway, after dengue, still on the subject of dengue, Serolytics, a very good data analytics company, took this idea, adapted it, improved on it, and entered it into the NASA Global Space Challenge, where they won the first place. So you see the dichotomy. You have a Philippine government company that does not value the data, and you have NASA that gave them the first prize. So I leave you to analyze what happens after that. That is one of the key things for data scientists. As Dr. Monterola has said, not only do you stand to gain to earn more, but more importantly, you can drive impact. You can create meaning in your life and leave a legacy. Next, we went to the problem of the poor internet what to do about that.
Run now.
So we decided to create a mobile
Ed.
app, speed test mobile app that we call projectpass.org. And this app measures Philippine internet signals and bandwidth. Armed with the bus data, we created two dashboards showing the fastest network in each municipality down to the barangay level for both Wi-Fi and mobile internet. So this is a win-win for all stakeholders. Subscribers use this dashboard when they need to choose a provider in a particular area. ISPs, cable TV operators, and even the large nationwide telcos use the dashboard to do QA or audit their field installations. We also supplied the data to DICT itself when they wanted the cell site tower data, and recently to DepEd and the City of Manila when they want to do bandwidth internet infrastructure analysis. So this is a win-win for all. So today, I'm excited to share with you how we can use data to fight COVID. These are some of the slides that we presented to the IATF as early as April of 2020. Something along the lines that Dr. Monterola presented to you, and that is now being used by the five areas. No? And this is what we call network graph analytics. I'd like to introduce this concept. What you see now is a combination of circles and lines. In network graph analytics, these circles and lines are used to represent relationships. It could be used to show friendships or the spread of ideas from one author to the next. Or as in the examples given by Dr. Monterola, how viruses spread from one person to another. But for today, we will use it to explain the spread of COVID in the Philippines. So for now, each of those circles represents not a person, but a city or a municipality. You will notice that the circles are of different sizes. The larger circles denote cities with larger population. Then we connect each of these cities together by their known travel paths. No? From one city to another, you will see lines connecting these two circles. We then give identification for some cities, A, B, C, D, and E. Now, look at this graph, network graph carefully. You will notice that some of the cities are more important than others. And one key way to look at it is by noticing how many links there are from one city to the others. I direct your attention to node B. So node B has 1, 2, 3, 4, 5, 6, 7 links. So it has the highest number of links of among the nodes in this visual. You know what that means? In network graph analytics, we call node B as something with a high degree centrality. In Dr. Monterola's term, this is a potential super spreader, as we will show later in our simulation. Next also, we'd like to see the high in-betweenness score. From one city going to another city, which other intermediate city do they need to pass through to get to the final destination? And again, in our illustration today, it is node B. It is what we call a node with high betweenness score in network graph parlance. Okay? So that is the theory. Now we show you the simulation. Suppose COVID hits node A. And suppose that every week, COVID will spread to the adjoining neighbor. Let us count how many weeks it will take COVID to spread from A to all of the cities in this illustration. So we count. First week, second week, third week, fourth week, fifth week, and sixth week. So remember that item. It takes 6 weeks to spread all over if it hits node A. Node A is is relatively isolated. It has only one link. Therefore, if the virus hits A, it spreads more slowly. But in contrast, let us see how the pandemic could spread even faster if it hits a high degree node like B. So again, we bring back the notation, and now we see that B is hit. Now, we now count how many weeks it gets to spread, because in the earlier scenario, it took 6 weeks. Now, in this scenario, it will take 1, 2, and 3. It will now take 3 weeks to spread. Therefore, if you were government, you would take pains to ensure that a highly connected location does not get COVID. Or if it does, the next possible step mitigation is to deploy blockage or movement control. So here, the government has to control only 3 routes, and it helps prevent the spread from B to A, C, D, and E. You see? So with that as a background, let's do a demo. Okay? The demo that I will be showing uses data from Facebook's Data for Good. I have access to this special data because of my work, research work with the Lee Kuan Yew School of Public Administration. So the tool I'm sharing with you is free to use, okay? So we get started, and then we drag the file that we want to analyze. There you go. And then we zoom out and go find the Philippines. So there you go, that's the Philippines. Now that we have the data in there, we would like to choose our visualization. For my purposes, I will choose the art, okay? Because we want to show the travel art. Now we will specify the starting location, denoted by latitude and longitude of the starting points. There you go. So starting latitude and starting longitude. Next, we will indicate the path. We know the start point. We also want to chart the end point. So here, we're inputting the endpoints. All the starting point will start with the color red, and all the ending points will color them green. This is a very busy visualization. Let's turn on 3D view. Okay, zoom in, and we can see all the travel patterns. This alone doesn't really give us much insight. So this is not the complete story. Now I will show you how, by using filters, we can craft a compelling story about the lockdowns in NCR. So here we'll limit all the lines to only those travels that started with NCR. And then we'd like to limit it further to show only those travels that actually increased. So Z-score is a mathematical concept of how many standard deviations from the median compared to pre-pandemic levels. So that's where you see that we're filtering it to those that are twice, 3 times, and 4 times more travel coming out of NCR during the period between the announcement of the lockdown and the actual lockdown itself. So you can see a lot of people escape Metro Manila. This was I think a suboptimal decision by the national government. You see? And all of those places I'm now zooming into are places that later on got the Delta variant. Guess where they got it? This is a very compelling visual to show how public policy can be further improved. And expectedly, 1 month later, September 6, Dr. Jomar Fajardo Rabahante tweeted this. The only thing to notice is that COVID cases increase in all the regions from Metro Manila. And again, we now have the data to show where it came from Metro Manila. So now we use the DOH data set. They update this every day. This was given in another talk for Cebu. Let's see how Cebu did in terms of the T3 concept. Testing, tracing, and treatment. So the first chart over here that you see is what happened. You will see two peaks for Cebu, and this is the x-axis is the date, 12-month period, ending October 1. Now let us show what the people did during that time. Kasi sabi nila, ay siguro because the spike could have been because pasaway ang mga tao. But in fact, Facebook's data for good show that people actually, majority actually stayed at home. This is the the orange bar. More than pre-pandemic period. Up to between 35% more people stayed at home. And if they traveled shorter distances. This is the blue bar. Next, we look at the actual government performance in Cebu. So the red line is the test positivity rate. When it goes up, it tells you that the government was not testing enough people. For Cebu, despite except for the peak, it now went down to 11%, and this is as of October. I would assume it would have been lower by now. So so far as testing, Cebu government did a relatively better job. But in terms of tracing, we can show that they're absolutely dismal performance at 0.08%. Poor performance. In terms of treating, however, the medical community in and around Cebu did a fantastic job at 0.00% fatality. So here are the numbers that tell the story and that will create impact, because these types of data, like what Dr. Monterola mentioned, in God we trust, all others bring data, right? Now here is something I think would create the most impact for COVID prevention. We note that there are studies that really said that, if you compare indoor transmission to outdoor transmission, indoor transmission is actually 18,700% higher than outdoor transmission. Now, why is this? My personal assumption is because this is in aircon environments. And you know what? In aircon environments, they close the windows and the doors. And what happens when you close all avenues of escape of air? The virus gets trapped inside, accumulates, and waits to infect its next victim. But that is just my assumption. Let us see what other people or scientific studies have done so far. And for that, we share with you a recent development. This is from Singapore. NUS and NTU scientists teamed up to create a device to measure viral particles in the air. So this is what they call air surveillance approach. Because honestly, we cannot see visually with our eyes if whether or not there are viral particles in the air. So they developed this device. And I point out some interesting results from their study. They found that COVID is more prevalent in the air than on surfaces. Because remember, initially when COVID first struck, everybody was saying, oh, it's fomite, it's on the surfaces, it's on the droplets. No. This study says it's suspended in the air. Shortcut, it's in the air. But not everyone can have a device like that. In the Philippines, who will have devices like that? So here's this simple idea garnered from another paper. Why don't we use carbon dioxide as the measure, as a proxy measure, to measure the risk of exposure? The idea is really simple. When you exhale the COVID virus, you also exhale carbon dioxide. If a room is not well ventilated, there will be an accumulation of carbon dioxide. And therefore, if you measure carbon dioxide and it is high, it means that there is a possibility of a high-risk exposure to COVID as well for those specific indoor spaces. Now, the next question is, okay, but at what level would carbon dioxide be considered safe or unsafe? For this, we share with you a study shared to me by Dr. Antonio Danz of the